Good afternoon, everyone. Welcome to the Vodafone Business Edge Innovation Program with AWS. We're very excited to be sharing with you today the first of several training programs and briefing sessions to help you get up to speed with edge innovation. Our goal today is to help you understand what is edge computing, how can you bring incredible experiences to life, and understand a little bit more about the solutions from Vodafone Business and AWS. The agenda that we have today is going to cover, first of all, what is the innovation program and how you can get involved. Secondly, the technology, what is edge computing from Vodafone and the different services that we have together with AWS. And then we're going to talk about some use cases, and then finally we're going to host a Q&A session at the very end. Throughout the program, feel free to use the chat functionality in the screen to ask any questions that you have. I'm going to ask that everybody stay on mute, please, and put your questions in the chat function, post it to everyone so that we can all see what your questions are. And then we will do our best from Vodafone Business and AWS to answer your questions as we go throughout. If you are having any sound issues, please contact Esther Frail. She is our host for today and can help answer and support us on any technical issues. Okay, so my name is Elena Branet, and I am the strategic marketing lead for Vodafone Business. And I'm going to be moderating the session today. I'd like to introduce as well Julia Merlo, who's our speaker from Vodafone Business as well. Marco Diaz Silva, who is going to talk about 5G and edge computing, and Saravanan, who is also going to speak from AWS Wavelength. Each of them will be giving an introduction to themselves as they go into their presentations. So what have we got on the Edge Innovation Program? So I'd like to take you through what that is. We've put together a program that is going to put you in a position of being able to change the type of experiences that you get in your applications and your services. This is a fantastic opportunity to really be in the driving seat and bring to life the innovations that you've always wanted to deliver, but you didn't have the reach, the power, the speed to be able to do that. Well, now you can, and you can do that through the Edge Innovation Program. And so what can you do? Well, we're offering a 3-month program that gives you access to Vodafone Business 4G and 5G network, as well as AWS Wavelength services in both UK and Germany. We're giving you access as well to key training experts and technical experts from both Vodafone Business and AWS. And we're giving you the opportunity to test and deploy the applications and edge services on the Vodafone network, on our multi-cloud, multi-access edge computing service, and to have that support from the AWS Wavelength cloud specialists. So if we move to the next slide, the timeline that we've got for that is in the first phase, we are running the technical training. The technical training is in this first phase is giving you the briefing overall, what is edge computing and how can you build for that. There are 2 options for this. The first is today. You have another option for a repeat session on the 4th of February. So if any of your colleagues did not get a chance to attend today's session, then there's a chance to listen in on that one. We are recording the session, so if you have any further questions, you can go back to that recording and review it. In phase 2, we're offering hands-on sessions and a virtual lab training for developers. This is going to be highly technical sessions where you're going to get hands-on access to the network, to devices from a remote capability, and the team are going to take you through some online labs to go through to give you some real-time experience. Those sessions are going to be on the 11th of February and the 23rd of February. And then finally, in phase 3, we're going to be selecting up to 20 projects to be deployed on Vodafone Business multi-access edge computing zone with AWS wavelength, and we're going to be offering you that special technical support from Vodafone and AWS experts. And you will have a chance to also meet industry experts who are serving as advisors for this special project. The goal is then to support you through February, March, and April to actually bring to life and to showcase your innovations on edge computing to the industry. So with that, I'd like to hand over to Julia Merlot, who is our product manager, who will take you through what is distributed multi-access edge computing. Over to you, Julia.
Thank you very much, Elena, and good afternoon or good morning, everybody, depending on where you are. My name is Julia Merlot, as Elena said, and I look after what here at Vodafone we call distributed edge computing. I just wanted to help you understand why Vodafone and AWS have decided to invest so much in edge computing. Certainly, we've seen some big trends and some data coming from research companies like Ghana, and they're saying that by 2022, already next year, more than 50% enterprise-generated and application data will be created outside of data centers and outside of the cloud. And from our own perspective, we've been seeing more and more interest from people like you and enterprises and some of our customers in exploring more of these edge use cases. And we're seeing this being 5% in 2019 in terms of edge use cases in production, and we're seeing them growing more and more. And we expect them to be around 40% of the edge use cases in 2024. So certainly a very exciting place where to be. But let me tell you a bit more, if we can move to the next slide, why this is important to Vodafone. As you probably know, Vodafone is a leading telecommunication company in Europe and Africa. Sorry, actually the slide before, if possible. And our purpose is very much to connect for a better future. You probably know that we've got the largest mobile and fixed network, and probably you'll be seeing on this slide some impressive numbers around. Actually, I wasn't even aware that we have 56 billion minutes per year of voice carriers. We are in 74 countries. We are the largest IoT provider. We have 103 million devices connected, and you can already imagine and understand all the amount of data that gets generated. With the rollout of 5G, Vodafone is actually the largest 5G network in Europe. We've got over 1,000 cell sites, and we, from our perspective, want to leverage on these mobile and fixed capabilities and build on them with our cloud and security services, and partner with the best, and in this case AWS, to really unlock innovation and really build on these new capabilities that edge computing does unlock. And we can move to the next slide, please. But what is really edge computing? So we've been seeing that some of you probably have embarked into a journey to the cloud. Some others have been born cloud native, and I think this is absolutely brilliant. You've been using services like the ones of AWS because you like the flexibility of it. You like to pay them as you go. You want to have agility in the way you use your infrastructure and you manage your application. But at the same time, you'll be moving data further away to where it is generated, especially if we think about, I guess, 10, 20 years ago, where we had data rooms just next door to our offices. And by moving them further away, this processing moves further away. We are more reliant on the network and on the internet, and sometimes we don't have the application performance or the latency that we wish to have. So what edge computing really does And you hear me talking about this as MEC, multi-access edge computing, that's the acronym, is really bringing the best of these two words together. The cloud computing piece and the strength and capability of AWS, but at the same time, the ability to be able to access to these closer data processing and computing power. And in this case, it is at the edge of Vodafone 4G and 5G network. And it is a brilliant union, if we can take one more time on the slide, because the conjunction of edge computing and 5G and mobile private network really does unlock new use cases and opportunities. And some of these are, for example, if you think about a digital traffic scenario where more and more vehicles get connected. Certainly from our perspective, we're trying to connect as many as possible, but when we're moving also to autonomous vehicles, we cannot allow for an autonomous car in the near future to not be able to detect that a pedestrian is crossing the road in front of it. We need this car to be able to respond to it much quicker than it can do now with the current technology. So this is where edge computing really comes to play, because it really does reduce that latency, that delay, and is able to allow for that autonomous car to respond and stop much quicker and avoid any accidents. I know that autonomous vehicle is something probably futuristic for some of you guys, but do start thinking about, for example, still in the automotive industry, real time as well as our warning systems to make you aware of what's going to happen ahead of you so that your car can alert you and hopefully help you stop so that you don't bump into the car in front of you that may have to stop because of a road accident. But also think about those use cases that we may have been seeing in the past, like AR and VR. I know that some of you are looking at this technology, and we certainly believe it is a game-changing one. But what we've been noticing is that it has been difficult to roll out these AR, VR, mixed reality solutions on a enterprise context, because sometimes when the latency is higher than 30 milliseconds, the user experiences motion sickness. So what Vodafone and AWS are doing here with edge computing is being able to reduce this latency and target to get it lower than 10 milliseconds between base station and where the application is hosted. This means that we can benefit from AR and VR solutions in enterprise context, and for example, roll them out for solutions to connect engineers remotely, to enable trainings. And I'll be telling you more about this together with Saravanan in the second part of this call. We'll be delving a bit more in the use cases and bringing to life, for example, some around IoT and the amount of data that gets generated, and some and other insights, for example, around video analytics, live video streaming. The idea here, if we move to the next slide, is very much to be able to really provide insights in a matter of milliseconds, to being able to empower you or your customers with this information so that decisions can be made much, much quicker. And this is why Vodafone and AWS have joined forces in this exciting partnership. The idea is to embed AWS wavelength capability, as I was saying before, at the edge of the Vodafone 4G and 5G network in Europe. We'll be starting with the UK and Germany, and I have an ambition to expand to all other European markets. So what does this really mean to you and to your customer is we are able to really unlock innovation. Decision making in real time means ultimately endless possibilities, from more immersive experiences through AR and VR, as I was saying before, but also combining AI to keep your workers in the field better informed and safer using, for example, connected robots, drones, devices. We are able to empower you to make the decision about where you would like to have your most critical data, most time-sensitive data, and make the decision to have it at the edge on wavelength if you really just need that lower latency to be able to, for example, manage complex decision-making and operations. We want to make you and your customers be highly responsive and totally in control, but still keeping that flexibility and agility that AWS does allow you to do so in region. Other benefits, if for example, we think about video analytics and video streaming and the amount of data that gets generated now that all the video cameras are connected to in 24/7, is the ability to remove some of those bandwidth constraints and throughput constraints that you or your customers may have. The idea here is that by you leveraging edge computing, MEC or wavelength, you and your customers don't need to think about, for example, dedicated on-site private networks or network investments. You can deploy your solution across the country and know that because it is at edge computing, you'll be able to access it through the Vodafone 4G and 5G and unlock these benefits. Other advantages, if we think about the fact that processing is moving at the edge, it means that you and your customers don't need to invest in buying the latest smartphones, the latest video camera. You can play with the legacy ones and make sure that this computing and processing power actually happens at the edge. This means a reduced cost in user equipment. Your devices could be slightly dumber, and you can also save battery, and ultimately we're all here also for the environment, trying to reduce those costs and from that perspective as well. All this new technology we're rolling out, and I said we are pioneering this in Europe, and we're very excited that you guys are here with us and interested to want to pioneer with us, making sure that we keep the same data privacy, security, resilience that you know that both Vodafone and AWS care so much about. So it is an exciting work from our perspective, and we really look forward to tell you a bit more as we go through the presentation. But now I talk to you about 4G and 5G. I know that you may have lots of questions about 5G, so I'd like to hand over to my colleague Marco, who will be able to tell you a bit more about what is 5G and why 5G is also helping enhance edge computing and unlock us further benefits. So don't forget to post any comments in the chat as we go through. We'll be trying to answer them as we continue with the conversation. And Marco, over to you.
Thank you, Julia. Thank you for that great introduction. You're making my life so much easier. Hi, everyone. I'm part of Vodafone Group Technology. I'm the MEC specialist, an expert in Vodafone on MEC and edge computing. I've worked on edge computing for a number of years, bringing it to life from a research perspective, moving on to platform readiness, and on to supporting and developing industry ecosystems. So look forward to engaging with all of you. I want to start off by recapping a bit at a high level information on MEC and telecoms technology generations. As Julia said, and very right, although in the press we might attach 5G and edge computing altogether, it's really technology that leverages the best of an operator's telecommunications such as Vodafone, and is available in a range of connectivity mediums. Whilst that it is true that a lot of the benefits come supporting to 5G, it's really important to understand what 5G radio technologies bring. As you can see on the graphic, 5G uses a wide range of frequencies. Some of them at the lower end is to also support and work alongside previous generations when you think of 2G, 3G, and 4G, and that's probably when we're going to use them for a wide range of deployments. At a mid-band level, it's what we consider a few gigabits in terms of frequency. This is where some of the marketed terms and speeds and latencies come on when we talked about single-digit millisecond latency, very high throughput. And that's typically an innovation that comes when the industry designed the 5th generation of a mobile network. Higher up the chain, then you have seriously high frequencies in the bandwidth. And this is really to target a lot of use cases for intense gigabit per second throughput in the very high tens of gigabits per second, and also to reduce further latency. Mind that this is very dependent on the circumstances and depending on your use case and also deployment scenario. Think about either a private network scenario, stadium, or a concise location where you need really an application that is super responsive but is very intense in terms of compute and bandwidth. And this is where sometimes those come in. So obviously from a Vodafone side, and working along a company such as Vodafone, we'll see with you through consulting of what is effective, what you need, and work with you for the deployments. Now 5G improvements alone over previous generations bring substantial improvements, not only in the spectrum efficiency, reducing retransmissions, reducing latencies, overall improving the overall channel. So 5G is not purely an innovation that happens in the radio domain, but it also happens in the re-architecture of the network. Henceforth, it brings substantial improvements. And that's where edge computing comes in as well, to provide further benefits by placing the compute close to the end user. Apart from what all these numbers mean in the low, high, and mid band, what is crucial to understand is 5G is there to support a wide range of applications, be that even applications that were closely related to previous generations, that worked in previous generations, and bringing that up to speed into the new technology, improving the quality of service, be that as well for IoT domains and the seriously high throughput that one may need in terms of capacity. So all in all, it comes combined to provide a best design and best experience possible for the best environments and new environments that you might deploy your applications in. Can you move to the next slide, please? Thank you. And as I was saying, this edge computing and 5G is not a single innovation. 5G innovation happens in the whole re-architecture of how we deploy a network, a mobile cellular network, and we're improving a lot underneath of how that's done in terms of communication. Edge computing, or multi-access edge computing, as we call it, is simply the fact of placing the compute where it is best suitable to run for your application workload. There's a lot of other types of innovations that comes from network slicing, typically mentioned in history, which is mentioned specifically on how it works together to complement and improve the quality of service and guarantees the quality of service throughout our network, specifically to your end application. Detailing and controlling how those conditions are performed, and then suitable deployment for that. Other things that are in the industry as well is what we call massive input, massive output. That is also taking about beamforming as well. These are most specifically at the radio domain, and this really stands out on how the radio new technologies not only improve in efficiency, but really leverage the details on how to improve the delivery of content. And only with beamforming, you're contacting with the best channel possible to improve the radio communication to the end devices that we're receiving. And with massive input and massive output, you have an increased range and scalability of how to deploy that content. And also in terms of resiliency as well. Consider this: if you have a lot more small antennas transmitting data to your device, even if one becomes congestion or doesn't work as well, you still have plenty others to do that. And then they will speed up and control even more and make it a lot more consistent. So I'd like you to remember is, whilst today we focus on MEC and edge computing, that is just one piece of the puzzle in terms of innovation that Vodafone is bringing towards 5G. Towards the next slide, please. Then I go, why MEC? Why edge computing? How do we make it happen? I hope this is something that you already found out by yourselves, or you can, or that you found out by your peers in your industries. But obviously, this is where the compute happens. It brings significant changes to the end-to-end quality of experience. You may apply this already in your applications, say as we heard from the closest AWS region. It might apply for different use cases where you have to deploy your application and scalable worldwide. So obviously, when we put the applications and when we bring the applications closer to the end users, we're essentially, when you connect to a region or anywhere else where the application may run, you go through the internet and our application servers that are in the cloud. You get good, decent service. This is typically in the several tens of milliseconds, as it is dependent on a lot of network paths, hops, and also on congestion paths. Why? Because it's where all the rest of the data goes. So in order to bring higher qualities of service and reduce these paths, what we are doing from a network perspective is placing this compute within the Vodafone network. So it doesn't travel through more data paths, it doesn't travel through congestion paths, and it doesn't have that unpredictability. The improvements are clear even when using current 4G. On a Vodafone, we also re-architecture our networks. So even for 4G, and of course that is applied to 5G as well, on how that improves the delivery overall. We mentioned that a few, say, 20 to 30 milliseconds or up to, and that is really quite relevant insofar on how a simple re-architecture, leveraging and thinking of improving the quality of service is key to deliver the end-to-end goal, which is to provide you with lower latencies, better consistency, better connectivity, and better throughput for your applications. In order to bring then these high quality of service, we reduce the network paths and we deploy the AWS wavelengths on a network location that is close to the end user to really deliver those promises. This goes all the way up to 8x improvements when we use 5G. Even more stringent set of requirements our applications may have, this might be the best environment and the suitable environment that you can think into deploy. So now we're talking about seriously low and much more consistently latencies provided by Vodafone for your application architecture to make use when deployed on the Vodafone MEC and on AWS wavelengths. So whatever the use case and technology you aim to use, deploy it on the Vodafone MEC for the best experience possible. And thank you. And with this, I pass to Saravanan, which will go through the AWS solution.
Thank you, Marco. Thank you, everyone, for joining. We are very excited to be here, partnering with Vodafone, talking about AWS Wavelength and why we built Wavelength and what problems it solves. I'm pretty sure you have heard Elena and Julia and Marco talk about all the innovation that happens on the 5G and how customers can actually benefit from the merging of 5G and edge computing and private networks and all types of possibilities that it will unlock for our customers to solve their edge computing challenges. I'm Saravanan Shanmugam. I am a Wavelength Solutions Architect. I've been with AWS for the past couple of years, come with a deep networking background as well as mobility background. So I'm super excited to be here to present about why we built Wavelength, what about the partnership with Vodafone and other carriers in the globe, and most importantly, go deep dive into how we built Wavelength and what are the things that happens inside Wavelength and why it is important to understand how Wavelength complements the region and how we help customers to provide an infrastructure wherever they want it in terms of deploying their applications and solving their challenges, right? That's the key goal of us, to bring in our services and infrastructure as close to our customers and solve their challenges, right? With that, let me actually kind of walk you through what do we call now as a cloud continuum, right? As you know, we all started with building AWS regions, right? We saw the need for building on-demand compute infrastructure and building managed services and providing the right set of infrastructure for our customers to solve their challenges, right? To bring in that cloud model. So that's how we all started. But as we moved on, as a couple of decades of working with customers, understanding their requirements and use cases, we know there are lots of use cases that cannot really work with the region concept, right? As Marco mentioned, all these traffic have to generate from some source. That source could be end user, that source could be enterprises, that source could be customers spread across the globe. So you are asking those data to be transported across the internet, ISP exchanges, to come to the region to serve these type of data, right? So we know like most of these traffic do work fine with what TCP kind of does its magic when you run your application in the region. But there are also certain applications which doesn't perform well, given the fact that they have to go through a best effort internet TCP or IP oriented protocol traffic, right? So that's where we started to think of how can we bring our services away from region and also take it closer to where the customers are, right? And that's when it started to think through, like, we have data that has to be processed on premise, right? As Julia mentioned, there are data sovereignty requirements, there are data latency requirements, there are other requirements that customers want to make sure that the data resides closer to them. So So they want to do processing on premises. And also there are some instances where customers are happy to transport their data, but not away from the metropolitan cities because of latency and throughput requirements. And also with 5G networks coming in, as Marco mentioned, there's a lot of innovation that is happening in 5G, which is providing us and customers like yours the requirement of creating tons and tons of data, right? Like sensors and other automotive industries like AR, VR applications. So innovations in the 5G network is going to radically change how we produce data and consume this data. So that's the key thing, right? If all these innovations are happening at close to the edge, just being in the region is not going to suffice and help solve customer challenges, right? So that's one part of the puzzle. So what do we do with that? You've heard about outpost, you've heard about local zones, you've heard about wavelength. So these are all, at the end of the day, these are all AWS infrastructure in one form or the other, right? I'm not going to go deep into other aspect. It's just one form of the other, extending the concept of our AWS services and infrastructure closer to wherever customer wants us, right? Either on-prem using Outpost, or either close to a metropolitan city using local zones, or even close to a 5G network, as we are going to talk today about wavelength, using wavelength infrastructure, right? Even though we have different names for them, if you really dig into all these aspects of different AWS technologies, they absolutely are powered by the same underlying AWS infrastructure, which what you see in the region. That's the power of these distributed architecture. We are not changing the way developers are going to deploy and architect applications when we talk about outpost and local zones and wavelength. We want to keep the same paradigm and the developer ecosystem when we talk about infrastructure and services when you get closer to the customer. Not only that, if you really go deep into the edge, where some customers say, I'm not concerned about the connectivity. Sometimes I really want a rugged edge infrastructure for my IoT, and I want to make like sub 1 millisecond latency. I really want that level of latency for some applications, right? For some application, right? So our customer needs is all over the place. We know that, right? AWS and Vodafone, they're all trying to come together and solve customer challenges. So there's a broad spectrum of services and infrastructure solutions available. And one such thing that we're going to talk about today and focus really is wavelength. What's the partnership with Vodafone looks like? How are we integrating wavelength together internally? As Marco kind of showed us a very high level slide of how do you access services today, and how can you access the same services close to the edge of the network by means of bringing that infrastructure close to a 5G network, right? So we will go deep dive into that. Okay, extending the AZs to Vodafone, right? Again, at the end of the day, all we want customers to know is we are working very closely with Vodafone and other carriers to really do the heavy lifting underneath the covers, right? And want to make sure that the customers are not being shown that complicated architecture underneath the covers. We really want to make it simple and keep the same logic of availability zone when it comes to wavelength zone. So let's take an example, right? Anytime, if you look at this slide, they're like right-hand side and the left-hand side, right? If you look at this, typically when customers deploy an application in the AWS cloud, they pick a specific region, right? And then they go and say, okay, I know my workloads, I want to deploy my workloads, and I want to serve my customers. Assume that in this case, the customers are in a mobile network, right? We are talking about 5G, we're talking about Vodafone, we're talking about mobile networks, right? So let's think about this, right? As Marco kind of touched upon this, I'm kind of like double clicking on that, on how packet flows, right? So if you have an application which is running in the region and your customers are mobile customers and you want to like serve them, how does the traffic flow today, right? Technically, if you think about it, the packet is basically flowing through the radio network packet core and the Vodafone backbone, where they're going to route it outside their backbone into an ISP peering exchange points, and then finally it gets to the Amazon backbone and then gets to your application which is running inside the region. As Marco again mentioned, that path is a best effort path, right? You can maybe do something about doing MPLS and all those things, but end to end, if you really take a step back and think about it, for your end user, end to end, they're using a best effort path, right? And the best effort path is going to come with a lot of its own challenges in terms of providing higher latency, variable delay, and certainly it's a shared bandwidth. What does it do to your application traffic? What does it do to your end user experience? As I told you, TCP is a magical protocol, right? We all know that TCP kind of handles all these inconsistencies in the networks very effectively, that most of the applications doesn't even see these type of inconsistencies in the bandwidth that connects your user to the end applications. But that's still fine. But with the way technology is evolving with 5G and all these type of new use cases that Julia talked about, and the requirement of AR, VR applications and other edge computing applications, which requires a lot of bandwidth as well as ultra low latency, this particular application or this particular network architecture falls apart, right? We can still try to push as much data as possible, but without the innovation of edge computing, without a think big idea here on how can we handle this data close to the source of where these data is being generated, we are not going to uncover and we are not going to solve most of the customer challenges when it comes to edge computing. And that's where we are thinking differently when wavelength with wavelength and with carrier partnership, right? So if you really kind of overlay what it does in terms of the actual radio network and the packet core, it's a very high level overlap, right? Or overlay what happens. Every carrier is different in terms of implementing how the radio network, and they really want to optimize the backbone, the backhaul networks, and then the things which connects the radio to the packet core. But at the very highest level, if you can overlay what are the different things that the packet flows through is the radio network, backhaul, packet core, data network, etc., right? When you see today, we are trying to solve the challenge, even without wavelength, we have been trying to solve this challenge, right? How do I bring individual services close to the edge of the network? Like AWS has pioneered in this space where we bring in CDN, for example, using CloudFront. We bring in global accelerators so that we can reduce the number of hops that the packet has to go through between the end user and the application. So you can get on to the Amazon backbone using global accelerator technology as fast as possible. And also we have Lambda at the edge. Like many of you might know that Lambda gives you an option of running simple compute executions at the edge of the network. So we are always trying to solve customer challenges by means of not just coming close to the edge as we are doing today, but even before that, for decades, we have different ways to solve customer challenges. But with 5G, we have to think differently, right? Because these are not just small computation that is required, or these are not CDN type of use cases. These are dramatically change the way that data is being generated and consumed because of 5G, what 5G brings to the table. And that's where we are trying to bring in and have a different thought process of how can we extend our region into closer to the carrier networks. By that, we are trying to eliminating the need for backbone. I'm not saying that we're completely eliminating, but when you need to access these applications close to the edge, there's no need for routing the packets through the backbone of the carrier as well as the internet as well as our backbone. We are going into carrier's data center, in this case with Vodafone's data center, getting close to their packet core, and then connect their data center back to the region using something called a service link. And then we introduce this concept of wavelength zone, right? As AWS savvy users, you know exactly what availability zone is, right? Availability zone is bunch of infrastructure, bunch of data centers in a location which connects back to other AZs, which comprises of regions, right? But what is wavelength zone then? Wavelength zone is typically a small subset of that AZ, right? Be careful in there. So a small subset of that AZ, the same AWS infrastructure, which is running in the region, is pushed closer to the edge of the network, edge of the mobile network, inside a carrier data center. As far as developers are concerned, all we are exposing is an availability zone equivalent construct. That's all it is, right? We don't want customers to worry about where these locations are, how it is connected back to the region, what are the infrastructure that is there inside the network, inside the wavelength zone, what type of routing that I have to do to make sure that my applications are routed properly in and out of the wavelength zone. All these are abstracted away, right? If you really compare that with the region, you don't really worry about how the AZs are connected together. All you're doing is you're creating a subnet, you're extending your VPCs, and as you extend your VPCs, one key concept that we're introducing is the carrier gateway, right? What is carrier gateway here? Carrier gateway is basically very similar to an internet gateway, right? When you actually deploy an application in the region today, and you want to serve your applications to the end customer, you typically create an internet gateway, right? Internet gateway basically provides a routing function and a NATing function to transfer your packets or route your packets from your private VPC into the public internet. That's exactly what carrier gateway does here. Carrier gateway is basically routing the traffic from your applications, which you're going to deploy in the wavelength zone, back to the mobile network. That's all it is. So that you don't have to route through the internet. You're basically self-confining your traffic right inside the carrier's networks. That's going to be a huge improvement for your application performance. All the throughput and latency that you're going to get by means of the 5G innovations, by means of the carriers expanding or investing heavily on the 5G networks to provide you the ultra low latency and high throughput network that Mark talked about, Marcos talked about. Those are the things that we want to leverage and also provide you the compute, right? There's no point in the carriers investing a lot of money on expanding their network and giving a lot of great features as 5G is concerned. But if your compute is still back in the region, you're still going to get in the bottleneck of the internet traffic. And that's where wavelength really solves the problem of not to go through many hops and trying to provide you an infrastructure which you're already used to in the region, the same construct close to the edge of the network. That's all wavelength is all about. If you really overlay the radio network, the backhaul, and the data network, wavelength sits right close to the packet core, right? By means of doing this, we're trying to eliminate all the unnecessary hops and trying to provide you the best of the best in terms of the 5G network that the carrier is going to provide, and also the best compute options that you get close to the edge, bringing the cloud model to the edge of the network. At a 10,000 foot level, this is what wavelength is all about. And when you go and start to experience and start to build your applications, it'll be very seamless for developers to think from an AWS construct perspective, but in this case, an edge computing paradigm, not deploying applications in the region. Again, I will talk about all the different nuances around what services are supported, how do you deploy an application, what does a reference architecture look like, what are the different customers, use cases that we have already seen with wavelength and things like that, right? With that, let me actually go a little deeper on what do we do with this. So now you know that, okay, I understood that you are actually bringing in the AWS infrastructure closer, but what does it mean to other aspect of the control plane? Like I've been dealing with EC2 and EKS and EBS and recognition, all these other services. What does it do to my services that I've been using and deploying applications? To answer that question, let's take a little detour, like maybe a couple of slides of detour on how AWS control plane operates. Right, today, customers are completely transparent to this particular aspect of it, right? As a user, you go, as I mentioned, you go to a specific region, like in this case, say US2 in London, you basically create a VPC, you create your subnet, and you spread your subnet across the AZ so that you don't want a single point of failure. So that's a best practice that always we recommend customers to spread their applications across different AZ so that one AZ failure is not going to affect the other AZ's application. So these are all best practices, well architected, and our customers absolutely know this, right? One of the things that I want to touch upon is, as we talk about Outpost and Wavelength and other distributed compute architecture that we're bringing to our customers, is there are so many things that happens inside a region, right? There's a lot of things happen. There's thousands and thousands of microservices actually works in the back end to solve the control plane elements, right? Say when you send an EC2 API, hey, I want to create an EC2 instance. I want to create an EKS cluster. I want to create a VPC. I want to send traffic through the internet gateway. There's a lot of things that you send by means of API, right? That powerful EC2 construct and other APIs, AWS APIs that customers and developers use today. But what happens in the background, right? There's a lot of things that happens. There's an API front end. There is a backend control plane which kind of manages all the stitching and combining these services together to give you what the customer wants. And finally, there are database instances which saves all the aspect of customer information on what VPCs they have created, how many subnets they've created, blah, 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 right? So there's a lot of things happens in the control plane element. Now, again, there's a lot of instances that runs and microservices that runs to actually execute that control plane. Let's zoom it out a little bit and see what happens when we extend this to the wavelength zone. Am I saying that as I extend my AWS infrastructure into wavelength zones, are we, and from a data plane standpoint, that's what the customers are, that's what is visible to the customer, right? You're not really worried about how the control plane actually operates, which is what we want, right? We don't want customers to really burdened by knowing what's happening in the control plane, but a little bit of knowledge on what we're trying to do with the distributed data centers and distributed wavelength zones is to understand a little bit on what happens in the control plane, right? So are we saying that am I extending my control plane along with the data plane when I bring wavelength zones to the Vodafone data center? This is one approach, right? Certainly this is one approach on bringing the control plane along with the data plane, but we know that there is no need for wasting compute resources at the edge of the network, right? These are premium locations, right? These are edge of the locations. They don't scale as big as the region, and we don't want to basically build and waste compute resources for building the control plane elements of the architecture. So what we have done is we have innovated so heavily. The VPC engineering team, the compute engineering teams, and all these teams put together a thought process on how can we extend the region without extending the control plane, right? Control plane is massive. We take billions and billions of API calls per second, right? Or per second or per minute based on the load of that particular region. And how can we do this without extending the control plane? And that's where we bring this concept of service link. Rather than running control plane element along with the wavelength zone, we are actually running the control plane only in the region and do some innovative architecture around running some proxies and making sure that there is no need for control plane elements running in the wavelength zone. That's the same thing for local zone. That's the same thing for outpost. So we don't want to waste the premium computes, and we innovated on new compute architectures, new networking architectures, new security architectures to make sure that the same level of efficiency is provided to our customers instead of wasting the resources on the control plane element. Just keep that in mind. Every aspect of racks that we're bringing in is completely going to run customers' instances and customer applications, not running any of the control plane elements, right? I just want to kind of highlight what we do with distributed architectures. So finally, putting all this together, we're basically doing this, right? We go to a data center, Vodafone, we create the wavelength zones, the same AWS infrastructure, and the most important thing, as you can see, is VPCs, right? The VPC logically extends. You don't have to do anything at all. You just have to create a new subnet as part of your wavelength zone. And once you create the subnet, when you map that subnet to the wavelength zone, your VPC is logically extending into that wavelength zone. And then finally, on the other side, we are technically connecting that data center using something called carrier gateway. Again, some customers, when I talk about this, some customers get a little confused on what carrier gateway is. Carrier gateway is not a hardware, right? It's a logical routing function per VPC, per customer, right? It's not like one giant hardware which is connecting back to the data center, which happens, right? Which happens in the background. But as far as customers are concerned, you are just focusing on VPCs, subnets, and carrier gateway. That's all it is, right? I've talked to customers, they're super impressed the way we have actually extended the concept of AWS region into the carrier's data center. Just 3 clicks of a button, like in 10 minutes. I can promise you that when you do the lab in the next session, when you join us for that, in 10 minutes, you will really get to extend your VPCs into wavelength zone by means of logically creating subnets. That's all it is. There is no new APIs, and there is no new programming model that we're asking developers to learn to deploy applications in the wavelength zone. That's really the key power of what we're doing with our programming model or underneath the covers. You can take this application that you deploy here today in a specific wavelength zone. You can take this to any carriers across the globe. You can take it to an outpost. You can take it to a local zone. In fact, you can take the application that you deploy in the wavelength zone back to the region. For some reason, you want to scale back into the region as well. Absolutely, right? So that's where the power lies. As we think through in a developer frame of mind, we want to keep that simple but very powerful when you deploy your applications at the edge. Quickly, the services, what type of services we support, right? I've been telling you that, oh, it's nothing but an availability zone, but the reality is we are only bringing the subset of AWS infrastructure, right? So customers immediately jump on and ask, so can I access all those 300 plus instances as well as instance types that you offer in the region? Can I access all these services that you offer back in the region, right? Today, we don't, right? And also, we don't necessarily think that developers need all those bells and whistles and all these services and infrastructure instances that is available in the region back in the wavelength zone. Certainly not. As Julia mentioned about all the different types of use cases that we have to solve for our customers. Those use cases might not require all the instance types. Those use cases might not require all the different tools that we have for developers back in the region. There is only specific tools and infrastructure that is required to solve low latency and high bandwidth applications. When we talk to developers about how do we actually architect an applications for wavelength zone, think of it as a hub and spoke model, right? The hub is always going to be the parent region. When I showed you in the previous slide, there's a wavelength zone which connects back to the parent region. It always connects back to one parent region. As we scale and add more wavelength zones, like in Vodafone infrastructure, these wavelength zones are going to be connected back to the parent region. So you always think from a distributed edge, and the distributed edge is all connected back to the parent region. So when you're architecting your applications, region is going to be where you're going to really develop and create your applications. But when you're ready to deploy your applications for edge computing requirements, for edge applications, you kind of distribute that across the edges. So coming back to the actual concept of what we're trying to say is, there is no need for all the instance types, and there is also no need for all the different services. But with that being said, we also work, as you know, we always work backwards from customers' requirement. We and the carriers, Vodafone, we're talking very closely with customers and understanding their use cases to see what services are really needed at the edge. But to begin with, we have to start with something, right? We know for sure that customers are going to deploy compute applications, right, which runs on top of EC2s. We know for sure customers are going to deploy container applications. That's for sure, right? Most of these edge applications, we think that containers are going to play a very major role. It's going to be highly scalable and highly stateless, and you're going to maintain some state back in the region, or maybe you're going to keep a ephemeral status or into your small high memory databases, right? So that's why we thought, let's start with key core foundational building blocks of any applications: EC2, EKS, EBS, and ECS. Those are the 4 services we natively support inside the wavelength zones, which provides developers to deploy compute and container-based applications. All right. What about the instance types, right? I've told you that we have like now 300 plus instance types after the reInvent 2020, when Andy announced all these new instance types. Now we have like 300 plus now. Certainly the 300 plus is not going to be available in the wavelength zone to begin with. And I said, there's no need for all these instance types. The instance type that we support today in the wavelength zone is G4 instances, R5 instances, and T3 instances. Why that is the case? As you can see from the slide, G4 is so key for a lot of applications which requires GPU-based requirement, right? Like video transcoding, real-time video transcoding, inference at the edge use cases, AR, VR use cases. All these use cases require access to a GPU. And that's where G4 instances, which has the Tesla processors inside, we bring that, right? R5. What does the R5 do? R5 gives you a good balance with compute, with X amount of CPUs, general purpose CPUs, and a high memory, right? A lot of the applications at the edge is going to be run from memory, right? We're not going to run from a spinning disk or from an SSD, because that is going to add a little bit of latency for your applications. So how do we reduce the latency for your applications by means of keeping all the application state and the code and the execution to run from memory instead of a back-end spinning disk. And that's why we thought R5 is going to be very important for a lot of these applications. And finally, T3 instance. T3 instance is a burstable compute architecture, as you know. So we know that customers are going to deploy load balancers. Customers are going to deploy API servers. Customers are going to deploy web applications, which is going to like the burstable compute requirements. So from that standpoint, we thought we should certainly have T3 instances. So that's why from a clean slate, we are starting with these 3 instance types, and we are always open for your feedback and your ask and your use cases to understand, is there any additional instance types that we have to bring to Wavelength Zone to solve customer challenges? Okay, and the last question, and some of the questions that customers ask me is, okay, what about other aspect, like the auto scaling group? Can I deploy an EC2 instance and scale in and out, right? One of the best features of running applications in the cloud, as you know, is the on-demand capacity and the auto scaling, right? Run whatever you want. Don't run instances which is not required, right? So the auto scaling is such an important feature for cloud concept and for our developers. Do we support auto scaling groups? Absolutely, right? Auto scaling group is not an individual feature, is an integrated service of EC2. So ASG is supported. CloudFormation, yes. CloudFormation for orchestrating your application and keeping your application as infrastructure as code. A lot of developers use them. So we support CloudWatch. You can deploy your applications. CloudTrail for logging in all the information about application usage and as well as infrastructure usage. CloudFormation, CloudTrail, Elastic Beanstalk, Cloud9, all the underlying management and CI/CD tools that customers are used to, that developers are used to, is still supported, right? The core foundational services and the management services are still supported seamlessly. As I mentioned, it's a hub and spoke model, right? We will talk about how in the next part of the presentation, we talk about reference architectures and how customers are actually using it, right? With that, we would like to take a 5-minute for question and answer, if you have any that we can answer together. And also after that, we would give you a 10-minute break, after which we'll start on use cases, customer references, reference architectures, and how we can actually, and then we'll talk about phase 2 and what phase 2 is about. With that, I yield back to Elena and to other participants if you want to ask some questions.
I'll actually jump in, Saravanan. This is Julia. There is a question here from Alberto. Sorry, actually, the previous one is from a user is asking, will a wavelength zone be priced based on the instance type, G4, etc., within its region? Will they incur an additional cost if it's their location at the edge? Before handing over to you, Saravanan, I just want to say that pricing is not available yet, as we'll be announcing it at launch, which is going to be in early spring in the UK for our London zone that is able actually to cover most of the UK, and in Germany later on during the year. But Saravanan, do you want to add something more in terms of the pricing at this stage?
Yeah, so the pricing is certainly, there is a little premium associated to the pricing when you run an EC2 instance at the edge of the network, especially in the wavelength zone. The pricing is certainly available for you to take a look in our public page. Whichever wavelength zone has gone GA, right? We have gone to GA with 3 other carrier partners across the globe. So you can certainly go and take a look at the EC2 pricing page. You should be able to drop down into a certain wavelength zone, and then there should be pricing for the 3 instance types that we support today, which gives you some comparative numbers about what is the cost of an EC2 in a region compared, when I say EC2, what's the cost of running an R5 in a region compared to cost of running an R5 in the wavelength zone. That pricing is absolutely there on our product page. And also, I just wanted to highlight a little bit on the pricing as well. That's the list pricing, right? So if you are a customer, if you're an enterprise customer, you have savings plan, you have enterprise discount plan with AWS, that still applies, right? That all those things that you have, that still applies to the pricing that you get on top of the list price. So I just wanted to highlight that point.
Thank you, Saravanan. Moving to the next question from Alberto Marti. What's the role that you expect the new Vodafone Plus AWS wavelength service to play in Gaia X? Any plans to join the project and X cataloging for providers? Joanna Newman from Vodafone, would you be able to take this question, please? We cannot hear you.
Hello, everybody. Can you hear me?
Yes.
Yes.
Super. No, that's a really good question. And Gaia X is a relatively new consortium that's only launched a few months ago. So Vodafone will be announcing our partnership with Gaia X or not in due course. I know it's something that we're definitely looking at.
Perfect. Thank you very much. Question for you, Saravanan. Are there any plans to reduce traffic costs out of wavelength to customer devices lower than normal EC2 traffic costs?
Got it. Yeah, that's a good question. Certainly, if you look at the pricing for running your application in the wavelength zone, there are two costs, right? One is from an AWS standpoint. One is certainly the compute cost that you incur by means of running a certain instance type for a certain number of hours, right? So you can always bring in your cloud strategy and cloud model in terms of, as I mentioned, auto scaling groups, run what you want, right? So there are a lot of best practices around how to reduce the cost by means of optimizing your compute usage and other tools that we provide to our customers. That's one aspect of the cost. The other aspect of the cost is the DTO cost. Absolutely true, right? There's no charge for ingress. As you know, even in a region, even in a wavelength zone, any traffic that is coming in, we don't charge anything. But any traffic going out, certainly there is an egress charge that we charge customers today, which is again publicly available in our page. So you know that we never raise prices, right? We start with a certain understanding of the market, understanding of the customer use cases, understanding the requirement on what it makes to help our customers to solve their challenges. So today we have this pricing, which honestly, it is a little premium price when it comes to DTO when you go out from a region compared to when you go out from the edge. So we are absolutely committed to work backwards from customers' requirement to understand what it takes to solve customer challenges, right? So all I can say is you will never see an increase in the price for sure. I can tell you that we have in our history we have never actually increased price of anything. We have always committed to reduce the price as much as possible through continuous brutal innovation, using our innovation engine and trying to reduce the price as much as possible for our customers.
Thank you, Saravanan. Moving to the next one from Manoy. Will the customer be able to use container orchestration in wavelength zone by to choose OpenShift, Ranker, or need to stick with EKS? Joanna or Saravanan?
Yeah, I can take that question. Absolutely, right? So we want to give options to our customers. That's been our story since day one, right? We don't want to push to a certain orchestration platform or even when you take machine learning, for example, right? We provide all the frameworks possible for our developer to develop applications on what framework they like to do, right? Exactly the same concept when it comes to containers. When we came with ECS, that's our container strategy or container orchestration platform. We thought, and we looked at the industry and we saw that customers are embracing Kubernetes as well, right? We don't want to push customers towards ECS because we want to give options. And that's where we came with EKS so that customers can choose ECS, our own container strategy or container orchestration platform, or EKS, which is the Kubernetes version, the managed Kubernetes version of Amazon. When it comes to OpenShift, absolutely. Since we have EC2 available, customers can certainly use an OpenShift orchestration and deploy their OpenShift worker nodes on top of EC2 and extend their OpenShift cluster into wavelength zone as they do today in any given availability zone, right? So fully committed to support any orchestration because we have EC2 underlying compute for deploying any orchestration. Julia, back to you.
Yeah, thank you very much. We've got one around, are you thinking to expose mobile network native functions through local MEC region like US localization, outdoor, indoor, or wireless pure synchronization, useful, for example, for some kind of evolved IoT? Joanna, would you be able to take that?
Sure. So again, another great question. I'm really enjoying all the questions that we're seeing here that follows all of our thought processes around how we think wavelengths will be used by you. And one of the things that we're definitely looking at is how we can expose some of the network functions that sit in our mobile telco core, like location-based APIs, etc., to MEC in the future so that they can be used. So yes, definitely something that we're looking at. Stay tuned. We're just at the very start of this journey to launch MEC processing capability.
Thank you. I know there are lots of other questions coming, but I think it would be good to take a break. Please take a 10-minute break, actually just shorter than 10 minutes, and be back at 1/4 past. Let's actually do 20 past to give you some more time. Yeah, speak to you in 10 minutes. See you at the second part of the presentation. Thank you.
All right, so we saw how wavelength zone seamlessly integrates into the carrier network on one side, and also how seamlessly the VPCs are extended back from the region from a logical standpoint, right? Even though there are physical connectivity that happens between the wavelength zone and the region through service links and other aspect of underneath what happens. So what we want to do in the next few slides is to kind of walk you through how the packet flows in and out of the wavelength zone, and what are the 3 different types of traffic flow pattern that our customers have to be used to, right? Because one of the key thing about wavelength, as you know, is developing applications so that you can reduce the latency and get the benefit of 5G network. And one of the key pillars of that is to understand the traffic flow when you start to define and design your applications. Where should I run my application from a latency standpoint? How does the traffic flow back and forth between an end device in the 5G network or the 4G network in the mobile network? And how does the traffic flow back to my region? Is it possible that I can even reach out to the applications which is running back in the region? Is it possible that I can reach out to some of an application which is running in the internet, right? Sometimes customers ask, there are certain reasons why customers want to go actually to the internet to access some of their maybe operating system patches or download containers, or even some customers want to push traffic to other parts of their network through the internet, right? So the key understanding of having a good understanding of the packet flows really makes a good sense for developers to get that picture, right? So the first traffic flow is the basic one is, can I access, say if I'm running a database back in my region, which is not in a latency sensitive path, right? Again, back to square one, right? Why we have to deploy applications at the edge? Only to certain extent where you have to serve your application a very low latency path. But it doesn't mean that your entire application has to reside in the wavelength zone, right? That's where the hub and spoke model always helps me to kind of get that understanding. Decouple your stack. We'll talk about this in the reference architecture. Decouple your stack. Microservices makes a very important play in this type of architecture, where you can look at your existing application stack and look at, these are some of my applications which really interacts front end with my end user, and these are some of the part of my applications which doesn't really interact in real time, which doesn't need to interact in real time with the backend system or with my client application. So how can I decouple? If I decouple, what happens to my connectivity? What is the latency that comes to along with it when I decouple my applications? So in this case, if you have a database which is running in the backend in the region, and you have all the front end applications, web applications and inference applications which is running close to the edge, how does the connectivity work? Do I have to do anything to make sure that I can connect back to my applications in the region? Absolutely, the connectivity is taken care for you, and as a developer you don't have to worry about that. Why? Because when we extend the VPC, as you can see from the purple small block here, we are also extending the route table of that VPC. So the entire VPC subnet, the CIDR block 10.0.0/16 is routed for you without you doing anything underneath the covers. So if you are pinging from a subnet in a wavelength zone to a subnet in the region, the traffic is completely taken care by us, securing it, encapsulating it, so that even if the traffic goes out of Vodafone's data center back into the region through the links, the direct connect links which connects back to the region, we encrypt that packet, and also we encapsulate it so that we don't lose what is the source VPC coming from, right? This is the case even in AZs, right? When you go from one AZ to another AZ, the traffic is encapsulated. But on top of it, since the traffic is originating from an external data center, which is inside the carrier network, we want to make sure that the traffic is also encrypted on top of encapsulation. So we have encryption and encapsulation so that you don't have to worry about all the underneath heavy lifting that we are doing to make sure that you have seamless routing between the region and the wavelength zone. That is one part of the traffic flow. What about the other one, the most important one, the traffic that originates from the 5G network, right, or from the carrier's mobile network, the IoT devices, the CV2X use cases where lots of OBUs and RSUs and cars and other IoT sensors and devices and cameras are going to send tons and tons of data, right? Terabits and gigabits of data is going to be sent from the mobile network back into your applications which are running in the wavelength zone. Absolutely, right? So when the traffic originates from the UE source address, and you're basically targeting towards something called a carrier IP address. If you look at this packet that I'm showing you in the slide, which I did not talk about in the previous slides, is what is a carrier IP address? I didn't touch upon that, right? I talked about what's the role of carrier gateways. Carrier gateway role is to do routing between your VPC subnets in the wavelength zone and the applications and the end user, which is in the carrier network. That makes sense. But what about IP addresses? Because when you deploy your applications inside the wavelength zone, you are only applying a private address, right? Anytime you deploy in an AZ or in a wavelength zone, this EC2 instance, which is running in the wavelength zone, gets a private IP from 10.0.0/16 subnet. So how will I communicate back to the devices in the carrier network with that private address? Absolutely not. You cannot. So anytime you want to communicate back to the applications in the carrier network, we have something called a carrier IP address. Guess what? It's very similar to the elastic IP that you're used to when you run your application in the region, right? When you want to serve an application to the outside world, you check out an IP address from Amazon's pool of IP addresses, which is called the elastic IP address in the region. But the same thing in the wavelength zone, it is called as carrier IP address. That's the only difference. We want to keep the naming convention different so that you understand what that carrier IP address is and who provides that IP address. The carrier, Vodafone, provides us that IP address, the pool of IP addresses. Why? Because that pool of IP addresses is routed by the carriers. It's not routed by the Amazon network, right? It's routed by the carrier network. And so that's why we give that naming convention of carrier IP. So when you go and deploy an EC2 instance, which we'll do in the lab in the next, in phase 2, if you participate in that, you'll see that when you deploy a container or when you deploy an EC2 instance, and you want that EC2 instance to talk to the external world, in this case to the mobile network, you have to assign a carrier IP address, right? So when you assign that carrier IP address, when your client is sending some application traffic, it is going to send from its source IP and the carrier IP address, which is going to be routed by Vodafone into the wavelength zone, and the packet flows through pretty seamlessly, right? But what happens is, because of the lack of route table, the only route table that this subnet knows is to route to 10.0.0/16. So the packet will get dropped without you doing much, right? You have to make sure that you have to create another route table, and that route table has a default entry going through the carrier gateway. That's called the custom route table, and you attach that custom route table to your subnet, which is running in the wavelength zone. And by means of doing that, you get two things. One, because of 10.0.0/16 local, you can get to the region seamlessly. Because of this default route, you can get to the mobile network. Very simple enough. Just couple of API calls or a couple of clicks in the console. You create a custom custom route table and create a carrier gateway. Attach that default route to that carrier gateway and attach that route table to your subnet in the wavelength zone. You don't attach this route table to the wavelengths, to the subnets in the region, right? Because you don't want any traffic that originates here to go through the carrier gateway. Absolutely not. You don't want to do that. You want to make sure that the routing is segregated, right? The routing, when I say it's disaggregated, right? This routing goes through the carrier gateway, and this routing goes through the internet gateway. It's kind of like a decoupled architecture. Keep that in mind. And that's why we introduced the concept of carrier gateway and also carrier IP, which is very similar to the carrier IP, which is very similar to the elastic IP you get in the region, right? Keep that in mind. And finally, the traffic going to the internet. So why do I have to go to the internet, right? As I mentioned, there are several reasons customer wants to access internet. Sometimes they want to download Ubuntu packages, or they want to download Docker containers, or they want to even send some application traffic to their own data center outside the carrier's network. So there are several use cases where internet connectivity is important. So the same route table, you route the traffic to the carrier gateway because there is a default route. With that, you can go to the mobile network, as well as you can also route traffic back to the internet as well. So if you really look at it, there are 3 traffic flows that customers and developers have to really look into when they architect their solution. Back to the region, back to the mobile network, and back to the internet. All this can happen, is possible if you when you deploy an applications in the wavelength zone. Guess what? Just 3 simple steps: carrier gateway, default route, custom route table. Exactly you do in the region. Today, you do the same thing in the region, right? You create custom route table for routing traffic from a private VPC, from private subnets. You create internet gateway and you attach that internet gateway to your VPC. That's exactly the same concept on the wavelength zone side as well. As nothing new to make you get started on deploying applications on a wavelength zone. Okay. One more traffic flow which I want to touch upon is very important is, how do I reach other services? You told me about how do I reach EC2 instances. You told me about how can I reach back to my mobile application user. You told me about how to reach the internet. But what about the key services that I use for my applications, right? A lot of customers use S3. Tons of, right? S3 is such a key critical component for different workloads when customers are deploying them in the region. So I have built my entire workflow. This is one from my one customer. I've built my entire video workflow using S3 as the object storage. Now I understand the value of bringing some of my compute applications close to the edge using EC2 or EKS. But I have to access S3. I have to write back my video objects or my ML related artifacts or my database entries into an object store, or I'm running some sort of workflow which writes objects back to S3. How do I do that today? By default, absolutely you can reach S3 by means of going through the carrier gateway, Vodafone network, internet, and Amazon backbone, and reach an S3 bucket which is running in, say, US West 2, for example, right? Because these buckets are confined to the region, so you have a region bucket which you can access and you can write into the bucket by default going through the internet link. This is certainly not the best path for you to write into the S3, right? Because you're going through, right? It's still okay. There's other option too, where you can still access S3 by means of creating something called an S3 gateway endpoint. I'm pretty sure developers are already aware of something, an S3 gateway endpoint. What does the S3 gateway endpoint do? It creates a proxy environment for you to write into a S3 bucket without going out to the public internet. So from wavelength, if you look at the route table, as soon as you create a S3 gateway endpoint, we create a route entry into your route table, which says, I'm sorry, it should be S3 EU West 2, right? I kind of kept East 2 as an example, but anyway, so for the region, we create all the S3 prefixes for that region is added to the route table. So it's based on the region, right? The route table entry. So right after doing that, what happens is any traffic, S3 traffic that originates from the wavelength zone from your application doesn't have to traverse the carrier gateway path. It can go through the service link using the S3 gateway endpoint. So customers can really decouple their architecture. run the core component of their application at the edge and still access, right? This is a beautiful thing. You can still access S3 and DynamoDB and Secrets Manager and CloudTrail, whatever it is that you are accessing today, using either VPC interface endpoints or using S3 gateway endpoints and DynamoDB gateway endpoints. That concept of accessing services from your private VPC subnet still holds true even with Wavelength Zone. That's what I wanted to touch upon. It's nothing new for Wavelength Zone. I can tell you that, right? Developers know for sure what S3 gateway endpoint is, what interface endpoint is. But what I'm saying is that feature is also seamlessly integrated into Wavelength Zone. There's nothing extra that you have to do for accessing your S3 bucket other than just creating an S3 gateway endpoint. Okay. All right. That's good. So I understand what wavelength is. I understand where wavelength sits. How can I logically extend my VPC? How you connect back from wavelength zone back to the region. I understand the different packet flows in and out of the wavelength zone. And also I understand how to access other services running back in the region. How do I know that I actually have access to a wavelength zone? Pretty simple. When you go to the console, you can basically look at zones under your EC2 dashboard and see what wavelength zones you have access to, right? There's a lot of things happening in the console. There's a lot of innovations, a lot of optimization that is happening in the console. And that's why I just want to touch upon, we will touch upon this again during the lab when we do in phase 2, like to understand what wavelength zone I do have access to. By default, if you go to your console today and look at the availability zone in EU West 2, like London region, you will see these 3 availability zones, right? AZ1, AZ2, AZ3, which is back in the region. How about the wavelength zones? How it is represented in the console? This is how it is represented. Today, as you know, we have a pilot site that we have that where customers are doing POCs, and that Elena talked about, that you have opportunity to deploy your workloads and test, and we will support you technically and help you kind of architect an application. All those things, you would be deploying it in a pilot wavelength zone till we go GA, right? When we go GA with Vodafone sometime this year, you will see a production public wavelength zone that comes in the console. If you go to, say, US East 1 today in the console, you can see other wavelength zones that is online today, publicly available with other carriers, right? We have announced GA, as I mentioned, with in Seoul, you will see with SKT, in KDDI, we have with in Tokyo region, you will see them. With Verizon, you will see tons of other wavelength zones which have already gone GA. But with EU West 2, with London, where Vodafone's wavelength zone is going to be GA pretty soon, but today you will see that pilot zone, right? What is that pilot zone? Pilot zone is where all the incubation is being done, all the new POC customers that we will talk about. How are they architecting their applications? How are they really understanding what 5G and 4G can bring to the table as far as wavelength is concerned? So all those pilot activities is happening with the pilot zone. That's why the name is pilot here, right? But when you go to a real production site, the naming convention will be very different, and you'll see tons of these wavelength zones start to appear, right? Several of them, I shouldn't say tons, but several of these wavelength zones as we distribute across the different geographies and add more wavelength zones for the distributed nature of this architecture. Okay. With that, let me jump into quickly EKS cluster, right? So I don't want to like go deep into every service and how it operates and what you have to do. Certainly we will go deep into this when we do the labs. We're actually going to do an EKS lab when you do it in the phase 2 again, not today, in phase 2. So how does EKS operates? I think there was a good question around OpenShift, right? Let's take a step back. I can also use this opportunity to explain to you how OpenShift can work or will work in this architecture. Let's go through EKS, right? When you deploy EKS today along with the region, so when a customer goes and deploys an EKS cluster, right? EKS, for the guys who don't know what EKS is, it's the Elastic Kubernetes Service, right? It's the version of Kubernetes that runs in AWS. We call them as EKS. So, okay, EKS. So what do we do with it? When somebody goes and creates an EKS cluster, why do I even create an EKS cluster? Because there is a need for deploying container applications, right? So customers are now moving away from monolithic architecture into microservices-based architecture. And when I talk about microservices, the first thing developers kind of think is, oh, in terms of containers, right? So I want to decouple my big stack into smaller modules and smaller execution stuff and smaller containers. And what helps to manage all these sprawl of containers and how do I auto scale and things like that. EKS makes it so easier for you, right? Kubernetes for underneath the covers. Kubernetes makes that package for you where you can manage your worker nodes, you can manage the scaling of these containers, you can scale in, scale out. Such an amazing way of managing your infrastructure using Kubernetes. So our offering of Kubernetes is called EKS. Okay. So now I know that my developers need applications to run as containers. I need an infrastructure where I can orchestrate the containers and manage the lifecycle of the container. EKS can help you do that. So when I create an EKS cluster, the first thing that happens is there are control plane elements that is deployed or installed in the region. Again, as I mentioned, we don't bring any of the control plane elements to run inside the wavelength zone because we don't want to waste that premium compute infrastructure. So when you create a cluster, make sure that you don't select a subnet in the wavelength zone to create your Kubernetes cluster, because it will fail, because we don't want to burn an EC2 instance which is running the control plane element of your Kubernetes engine in the wavelength zone. So every aspect of the control plane runs only back in the region. And then what happens? Then you go and do the second step of deploying Kubernetes worker nodes, right? This is where you deploy your containers and run your containers at the edge. Such a cool concept where your control plane still runs in the region and your worker nodes are all deployed in the wavelength zones. Think about it, right? So you have a distributed environment. You have millions of customers distributed all across, say, UK, and you have wavelength zones popping up across close to where your customers are. You create an EKS cluster, and that cluster control plane still runs in the region, but you can deploy your containers all across the wavelength zones in different geographies based on your requirement, based on where the traffic is coming from, and scale in and scale out in a very different fashion, right? Maybe Manchester, you might actually scale a little bit because your customers might be very little presence there. In London, you might actually scale so big because there's a lot of traffic coming from London. Such a cool concept of distributed edge and distributed scaling based on your customer's requirement rather than just scaling in for peak, right? That's such a cool concept of when you add distributedness into this picture, right? So what do I do? What are the things that I normally do with creating a cluster? You create a cluster, you create a self-managed node where you're creating all these container instances at the edge of the wavelength zones, and you create some endpoints, right? Again, I don't want to go deep inside this because we will actually do a lab when you do this. And one key reason why I really want to touch upon this is a lot of customers have challenged understanding the concept of EKS and how wavelength and EKS kind of comes together. There's no secret sauce of creating an EKS cluster in a wavelength zone. It's just that minor nuances around carrier gateway, carrier IP, and some of the interface endpoints that you have to create to connect back to the wavelength, to connect back to the region, to attach to your control plane so that you can start deploying your containers in the wavelength zone, right? So as a quick animation of the steps that I've showed you here is you create a cluster where a control plane element is created. You create a self-managed node where X number of EC2 instances created as container instances where you can run your Docker containers. And then you create an EC2 API, you create an ECR interface endpoint, you also create an S3 gateway endpoint. Why do I have to create all these things? Because as the container instances are created, it needs to access EC2, it needs to access ECR for downloading POS containers, and also it needs to access S3 for downloading some configuration files. And that's why you need to have these three things, three interface endpoints created as part of that entire package of creating an EKS clusters. Some customers have run into challenges. Even yesterday, I had a debugging call with one of my customers, helping them kind of onboard an EKS cluster so that they can deploy their applications. And that's one of the key reasons we thought that touching upon EKS is very important so that we make sure that developers who are very savvy in deploying container applications or who are developing container applications understand that running EKS is very seamless. It's very, very easy to extend your EKS cluster into the wavelength zone. Okay. With that, I will actually yield back to Julia to talk about some of the use cases that we have been seeing with customers, and also some references about customer and what they did and what they're going to do. Lots of cool stuff. So back to you, Julia.
Thank you very much, Saravan, and very, very great to hear more in detail how a wavelet works. If we can move to the next slide, what we're this captures a non-comprehensive list of some of the edge computing use cases that we've been noticing in the market. We've been hearing from some of our conversation from the customer and the partners we've been working with. The list, I said, is not complete, as we are finding out more and more every day. And also the industries are, these are just the main ones, but we've seen several edge computing use cases, for example, in the financial services that you may not see on this list. At the beginning of this call, I did tell you a bit about a couple of use cases. I mentioned V2X, I mentioned AR, VR, but the applications are very much can vary from industry to industry. So if we use, for example, a mixed reality solution, we are in discussions with some of our utility customers in the UK so that they can enable their field engineers to perform their jobs while doing it remotely, without using their hands, by using AR headsets, and be able to activate them by voice, but at the same time to be able to collaborate remotely with some colleagues in other parts of the country, and also to be able to train newer colleagues remotely. This is particularly relevant if you think about the pandemic nowadays and not allowing us to be closer together or to be in the place where we'd like to be. So certainly very, very, very relevant. Other use cases that we've been noticing is anything around advanced gaming to really unlock the capability to for those people that want to have an even more enhanced experience to benefit really from this real-time capabilities. If we instead think about how this can apply to broadcasting, and I mentioned at the beginning of the call, video and video streaming and video production in real time is certainly something that some broadcasters and video producers have been looking into when leveraging mobile journalists, for example, or people from the audience in creating video and then producing it in real time while an event happens. Public sector smart cities have been really interested in understanding how computing use cases and solutions can be relevant for them. And in particular on this, I'd like to talk to you about what we have discussed with some of our pilot customers in the UK. If we could actually go back to one slide, Saravanan. We've been working with a company called Undish. There's a video analytics AI solution provider, and what we've been working on with them is very much enable them to enable public transportation in the UK, and especially in London, to help prevent accidents, and in particular also help prevent suicides. What video analytics can do now at the moment is really take all this massive amounts of data and stream it to the cloud, and events can be captured after they have happened. So unfortunately, not much can be done after a tragedy happens. So instead, by deploying video analytics at the edge and pre-processing them, as we are doing with Unleash Live, these transportation companies are empowered with real-time insight about something, an emergency potentially happening, and they really can do something to help prevent it. So I think it's really exciting when we think about these scenarios, and also think about how video analytics technology can be used, for example, for face mask detection, crowd monitoring, public distancing, safe distance in terms of the minimum space that we have to have between us during these difficult times. I think the use cases are many, and certainly public sector, the travel and transportation and logistics industry have been really keen to understand how this technology is relevant for them. If we move to the next slide around the pilots we did in the UK with digital barriers, they also are looking at using video analytics capability in real time, but focused for real time responders. So here, think about a police policeman, a policewoman that is sent on location and is able to communicate in real time with video analytics and show her colleagues back in the control room at the police station what the situation is, so that they can they are able to respond and send support if required, or prepare everything where they are to make sure that they can really are able to keep us all safe and control the situation in a much better way. But we're also working with digital barriers to understand how this can be used in a healthcare scenario. For example, with connected ambulances, empowering first responders to be able to be more aware of the situation that is happening, so that hospitals can be better prepared with resources and equipment, so that if they need to assist somebody that has to be taken to the hospital, they know exactly what went on, what treatment that they've already been given, and they can make sure that that person is better taken care of. I really, really like how this technology and working with these companies is really making us safer, making us really empower police or healthcare to support us and make us feel safer and healthier. Another use case I'd like to talk to you about is a pilot with GroupView. GroupView is a really cool startup I see that does collaborative social viewing. Here, think about that time that you had to watch your favorite football team a match. They were playing the final, and you were watching it with a friend of yours that was in another city, and you were trying to watch it with. So frustrated when you found out that your favorite team scored, and you only found out because you heard your friends cheering about it, whereas you didn't see it happen at the same time. What GroupView does when embedding their solution at the edge is ensure that there is synchronized live video sharing, if it is a football match or a movie, but at the same time embedded with collaboration tools, chats, emoticons, and I really like this use case specifically, especially now as I'm not able to be close to my family back in Italy, and I think it's a brilliant way to see how technology can bring us all together and feel closer to each other. The last case study I want to talk to you about is the one with Here Technologies. They're a big multinational that focus on location technology. We are looking to start a pilot with them in the next couple of weeks in Germany. And this is, I guess, very relevant to the question that Stefano Medley asked a couple of times on the chat with regards to V2X and mobility. What we're looking here to do is really empower OEMs with real-time hazard warning systems, not only for the vehicle drivers, but also for the pedestrians. It is in preparation to digital traffic for smart cities, and the idea that drivers can find out in real time whether there is an accident, so that they avoid bumping against each other. They can prevent accidents, and they are more aware of what's going on. But at the same time, pedestrians can also be aware of a situation, understand that there are some cars coming their direction, and eventually try to avoid fatalities. I think it's something very exciting that we are doing with Here, and I'm really looking forward to seeing how the automotive industry can be disrupted by combining edge computing with this real-time insight and hazard warning system technology. The last use case I want to talk to you about is with Dedrone, but rather than hearing it from me, I'd like to play a video that was done with them during a pilot in the UK.
Dedrone provides complete airspace security for organisations looking to protect against unwanted drone activity.
Vodafone Business and AWS are coming together to deliver multi-access edge computing for Dedrone. Dedrone's technology is all about keeping key sites secure. So think about ports, airports, large campuses where you've got important activity going on. And when you do have a drone that comes into the area that perhaps could even be a threat, knowing that as quickly as possible adds value to the business.
When it comes to responding to drone threats, time is of the essence. With the integration of Dedrone's counter-drone platform into Vodafone's Net solution, customers can quickly and easily extend their security systems to protect lower airspace against the drone threats.
Vodafone Business and AWS are so excited to be coming together to provide multi-access edge computing to Dedrone.
Thank you so much for playing the video. I'm just so proud when I see that Vodafone, AWS, and Dedrone coming together can make sure that we keep ports, airports, national critical infrastructure safe by being able to really provide real-time alerts if there are malicious drones flying in a certain area. So absolutely thrilled to be working on this, and I'm really looking forward to understanding how we can work with some of you in the audience on pilots and how we can unlock and some of your use cases and have them deploy knowledge computing. But Saravan, why don't you tell us a bit more about some of this architecture of these use cases in the next 15 minutes, please.
Thank you, Julia. Yeah, that's certainly exciting to look at that video and see how the power of 5G and video analytics at the edge combined with the wavelength. It's such a cool use case, and which can be done with the region, but with only by offline methodology, right? So real time, if you really looked at what they mentioned in that, was real time information gathering and real time information processing and triggering the action based on what you have done with the data is so very critical. And with that being said, let's quickly look at a typical reference architecture, right? As I mentioned, we have been working with several customers globally on this edge computing journey and understand their use cases and how we can solve their challenges, right? That's been our strategy forever. And so looking at that and learning from our customers, we kind of put the slide together to really showcase what a typical reference architecture would look like for edge computing, right? So again, walking back a step, regions, right? Every aspect of compute that we have is available in the region. Every aspect of services that our customer need is available in the region. But that's not going to help these type of unique use cases where you have to really process this data close to where the data is generated and trigger some actions, right? Like Unleash Live, for example, that Julia mentioned, Dedrone, for example, how they actually have architected this solution. Without going deep into their architecture and logical diagram and reference, I just want to highlight a very 5,000-foot level view of a reference architecture, right? That's what I'm saying. Like if you look at how it's all connected, now you know how a wavelength zone seamlessly connects back to the region as well as to the packet core network on one side. So let's take inference at the edge use case, for example. Inference at the edge, right? It is going to power a lot of use cases. It's not a specific use case. Any use case you take, Unleash Live, for example, Dedrone as another one. The automotive use cases from here that Julia mentioned. Every aspect of these use cases, either they fall under public safety, either they fall under automotive use cases, either they fall under any vertical that you think about. Inference at the edge is the key foundational block which is going to power all these analytics. In this case, if you think about Dedrone use case, all right, or your use case, what they're trying to do is they're trying to send data in terms of video frames, iframes, whatever it is, right? So you're sending streaming video using RTMP protocol or SRT protocol or WebRTC or whatever it is, right? The transport protocol might vary, the signaling might vary, the type of codec that they're using might vary. But if you take off all these complications away and you look from a very abstract way of looking at what this edge computing architecture looks like, is some source is sending streaming video and you have to process this data as fast as possible. And the network gives you the capability of sending gigabits of video, right? When 5G rolls out across and all all these MIMO and network slicing that Marcos talked about, is going to provide you that capability to send these feeds directly into the carrier's network. And by means of inserting wavelength in the path of that packet, as close to where the packet core is, and providing you G4 instances and providing you R5 instances, you can bring your model, your machine learning model, close to the edge of the network and process this data and do real-time AI analytics at the edge, not sending the data all the way to the edge. So the G4, the instances that we talked about, comes in handy for running your ML workload at the edge. Guess what happens? It's not the end of the story, right? The models, as you know, has to be constantly updated, has to be constantly improved, has to be constantly optimized. There is always this concept of ML ops, right? These days, ML ops is so critical. You have to improve on your ML ops or ML model. How do you do that? The best way to do that is to use the data set that is being collected in production. What is that data set? The data set which is coming from your LiDAR sensors or radar sensors or cameras, all these data is coming from the field, and you're running the model against it and doing inference at the edge in real time. But the most important thing is, how do I improve the model? Send that data back using the service link. That's the beauty of this architecture. In a wavelength zone subnet, you're running your real-time inference. In a region subnet, you are running your model creation and model implementation using SageMaker and other tools. That's the combination of the services that I was talking about at a very high level abstract, but with a specific use case. This gives you that ML ops, DevOps, CI/CD kind of a platform. Not just the specific tools I'm talking about, I'm just laying out a foundation or a framework of how edge computing works and how you use the power of edge and the services back in the region to combine them together to solve real-time customer challenges, and also to constantly improve your efficiency and performance of the application which is running in the edge. Okay, let's move on to another one. Like, for example, analytics at the edge, right? There are not even just video frames. There are a lot of IoT use cases that we are going to talk about, like location services and other safety use cases, that where RSUs and OBUs and other devices in the car, outside the car, in the road, right? The cameras, the lights, the street light cameras, every aspect of them are sending some measurement back to the data set, right? Creating this enormous amount of data set. What do you do with that data set, right? You're improving the safety of the drivers, the passengers, the pedestrians, the rail tracks, right? Every aspect of utilities in the road can be improved, and safety can be improved and save lives. And that's where these sensors measuring these data is so critical. Again, you can send this data all the way to the region, but it's not going to be of much use if you cannot react and make some actions back to the source of the data. That's the key aspect of it. And that's exactly what we are doing here. Bring in the model, bring in the compute, bring in your applications to the edge of the network and do things that you have to do in real time, but still keep pushing the data for doing offline analytics, improving your model, dashboard, and streaming stats to other parts of your applications and to your organizations to look at what's happening, right? In fact, some of the customers have even asked us, can you proxy that data so that we can do real-time analysis at the edge of the network, and also non-real-time analysis from the region to other parts of the network, right? Maybe in the case of Unleash example, the users and the actual source of the data and the consumption of the data happens at the edge, but still other parts of the application still needs access to this data, so you can seamlessly send to the region and consume and drive other parts of your application. I'll be a little fast from here, like automotive example, right? Instead of talking about the technical stack, look at automotive examples. Look at smart factory and robot example. Look at media and entertainment examples. Media and entertainment is also such a key function of edge computing, where there is a dramatic thought process change in which broadcast industry can leverage 5G, right? There are several use cases that we have already publicly referenced. And there are several more that the customers are dramatically thinking on how to leverage 5G with edge computing for changing the broadcast industry, changing the CDN industry, changing the way we consume and serve our customers for real-time video streaming, AR, VR use cases, 360-degree video experience, immersive experience for our customers. There are tons and tons of use cases. But if you all take that thing away, and if you really look from a reference architecture standpoint, it becomes so simple. It becomes so easy to really get that concept of distributed compute, distributed application processing and architecture, and how to connect my application from the region to the edge and to leverage the services that AWS brings to the table. That's where my role becomes very challenging as well as very, very, very interesting. Talking to hundreds of customers across the globe, understanding what their needs are, like myself and Chris, who's also a part of this call, who's another solutions architect, part of my team. We have so much of passion and energy. Go and talk to you and understand your use cases and work with our carrier partners to solve end to end, right? It's not just bringing wavelength. Let me be very honest. It's not like just bringing the compute at the edge. It's the partnership with the carriers. It's the partnership to see what network can bring to the table, what compute can bring to the table. How can we work together to solve these challenges? There was one great question about private networks and location APIs. Absolutely key. When network slicing comes to production, when these network APIs becomes a reality, how can we solve much more easier than what we do today? How can we bring the power of 5G with carriers and edge compute with wavelength together is what we're trying to solve. So a quick overview of the reference architecture. How do you connect the services? And more importantly, developers need certain tools to keep developing applications, right? They're not going to come and deploy a CI/CD pipeline and run the management plane inside the wavelength zone. They need to actually keep the code pipeline, keep the other aspect of technologies that they are used to still in the region, deploying all the applications and creating these applications using Cloud9 and other stuff that we have today, but still have the seamless mechanism to deploy these applications to the edge. This slide kind of gives you the entire picture on what we think in terms of edge compute. It's not just wavelength, right? If you replace wavelength with local zone, if you replace wavelength local zone with outpost, if you replace local zone with the snow devices, right? These are all different edge computing options we have that we want developers to look from a very big angle to solve distributed edge compute challenges. But when it comes to 5G and the spurn of use cases that we're going to see, and how we solve that with wavelength is what the key concept here I'm talking about. If I have to like basically overlay some of the use cases that is already publicly referenceable, like Savari, Harman, LG, which has been doing automotive CV2X use cases that Julia touched upon here, for example. Those are all use cases which falls under the automotive bucket. What they do with that, right? They need some messaging bus. They need an ML model. They need some cool data analytics platform that they can run in real time. They can do lots of aspect for autonomous driving. Level 4, level 3 is all coming very soon, right? How do I deal with that? You can pack as much GPUs as possible inside the car. It can do a lot of things inside the car, but there's going to be some need to burst out of the car in certain situations, in several situations where the onboard compute is not sufficient. You have to have connectivity to the network as well as the computes at the edge of the network, which provides you sub 10 millisecond latencies or sub 20 millisecond latencies, and also provides you the necessary bandwidth and capacity to do inference at the edge use cases. So if you really look at what automotive use cases are doing, even though we target Harman, Savari, LGs of the world as an automotive use case, but technically underneath the covers, if you look at their stack, if you look at their application reference model, they're basically doing inference at the edge. They're basically doing analytics at the edge using MQTT message bus, MQTT IoT core, and all those things, integrating that with the IoT core in the region. That's exactly what they're doing. If I move on to like the smart factory and robot use cases, like the brains technology, TCS, we have been also working with TCS on their smart factory industry 4.0 initiatives, right? What they're trying to do, exactly reference at the edge, analytics at the edge. So if you ask me, the key pillars are the reference of how do I run inference and analytics at the edge. Every use case will potentially fall under the same bucket, right? Let's look at Unleash and Dedrone. Pretty much they do inference and analytics at the edge, right? Sending video feed, sending feeds from radars, sending feeds from LiDAR sensors and other sensors, and doing some analytics in real time. Another one is media and entertainment. As I mentioned, such a lot of excitement in the space, a lot of cool innovations from the devices side perspective, a camera which can be fitted with a 5G receiver, which can actually transcode internally and send feeds directly over the air rather than investing a lot of money on fibers and OB trucks and things like that. We know there's a long way to go, right, to eliminate all the broadcast gears that goes into a stadium during an event. It's a long way to go. Certainly, we agree. But the industry is on track to get there if we all work together, right? The manufacturers of the equipment, the carrier providers, the network, the compute. If we all work together, broadcast and media industry is up for a massive revolution in terms of leveraging edge compute and enhancing the user experience, either it be inside the stadium for the audience or for the fans or the viewers all across the globe, what they can do with edge computing. And finally, and again, Group View, Zixi, these are all some of the examples that I can touch upon. Quickly, I want to basically give a simple flow of couple of use cases, right? Technically, without 5G, without 4G, without wavelength, how the customers are doing architecture today, right? CrowdVision as an example, Unleash Live, Drone, these are all examples. Without wavelength, what can I do with it? The first thing that I can do is, because my applications need ultra low latency, the only way I can do and handle this type of application requirement is if I run inside the airport, inside the venues, inside the malls, and other aspect of use cases, which needs ultra low latency of 20 millisecond or less. I can't do with the region, right? I cannot do that with the region, because if I have to send the video feeds and the sensor data through a 4G connected device to the internet IP network, again, Marcus talked about, and I talked about all those best effort path, is not going to give you that consistent bandwidth and latency for sending these feed, processing at in the region, and sending back the information back to the source of the data in 20 millisecond. That is next to impossible, right? You might get here and there if you're very close to the region, but in a distributed fashion, it's going to be very hard unless you have direct connect or other types of technologies you can use, but not at a scale, certainly not at scale, right? So customers have been doing this architecture for a long time, but what they've done is they invest on computes, they run their model and the databases in-house, either in a stadium or in a mall or in any venues. They're running with x86 platform right inside the network, inside their local area network. And also send data. Certainly they are sending data to the cloud for what? For analytics processing, for storing, for archiving, for doing lots of cool things with offline data processing and start streaming to the applications, right? But not in real time. All the real-time applications that they're doing is still being run inside the venues using a compute that they have invested, and it is being in the stadium. And it's very hard to manage these computes. As you know, the IT infrastructure investment is going to be very hard to manage, and also constantly improve the model and keep it up and running is very, very hard. Think about what they're doing with AWS Wavelength. With 4G and 5G capabilities, you can basically eliminate the need for running your on-site compute and move that to the wavelength, use the instances that is available today, and run your application stack, analytics stack in the zones, and also seamlessly use the service link to archive your data in S3 and do further offline analytics. And instead of sending your statistic streaming back to the source of the data, there are several use cases, right? CrowdVision, Shot Tracker, Drone, several ways to do it. But one of the key thing is I want to send this data as quickly as possible back to the source of the data for consumption, right? By the cameras or by the coaches or by the Jumbotron, which is there in the stadium, to give real-time overlay of analytics over the medium. How can I do that? You can certainly do that by means of leveraging 5G and edge computing and running your analytics processing in the wavelength zone. Quickly, machine learning at the edge, right? Analytics at the edge, machine learning at the edge. I can give you tons and tons of examples as far as examples are concerned. Industry 4.0 initiative, Smart Factory. Again, lots of use case, lot of customers have said, we have invested in running the model in the factory floor, in the IT closet. How can you help me to reduce the investment that we can make and leverage the network capability and the edge computing capability? Exactly what happened. As you can see, you might think that I'm like a broken record of what I'm saying, but that's what edge computing is. We bring in the power of AWS cloud to the edge. Vodafone gives you the power of the 5G connectivity, 4G connectivity, and all the new technologies that is going to drive 5G. Combine the power. see what you can do with this technology is amazing. And we have been talking to hundreds of customers to solve their challenges. And with that, I just want to touch upon some of the questions that comes most often about the security and compliance, right? Customers ask me, that's cool. I can see what the power of wavelength is. I can see how to get started. I'm so excited about this. Wait a minute, what about security and compliance? You know, when it comes to security, myself and pretty much everybody in Amazon talks about security as day zero for us, right? It's so critical that we value and how much importance we give to security of for our customers, right? There are two aspects of security when it comes to AWS. We always talk about that: security of the cloud and security in the cloud. We AWS is responsibility to take care of the security of the cloud, the physical nature of the infrastructure, the access to the physical infrastructure, the operating system that runs, if you're running our operating system, the physical droplet or the server. So that all comprises security of the cloud, right? Security in the cloud is there is a shared responsibility model, right? We call this a shared responsibility model. That doesn't change when it comes to wavelength. It's not that we are coming up with a new paradigm for security. We certainly have to look bigger in terms of security, because the workload is not running anymore in the region, in the premises of AWS region. It is going beyond the premises of AWS region inside the carrier's network, inside the carrier's data center. So security is of paramount importance for us, even in the region, but now it's doubly important for us to see what are the impacts of security for our customers' workload when it runs beyond the physical realms of a region. So, but the model remains the same. We provide the necessary tools and methodologies like IAM, for example, security guard. There's so many services, security services we have for customers to deploy their workloads in the cloud and manage their responsibilities in the cloud with the tools that we provide and the recommendations we provide. So that model doesn't change. That absolutely doesn't change. But and when you expand that, when I say security of the cloud and security in the cloud, when you double click and expand that, what does it mean then? What are the things that AWS takes care, and what are the things that customers takes care? We provide all the necessary tools of firewalls and operating systems and customer data. All these things, customers are provided with the right set of tools for them to implement security in the cloud. Security of the cloud, the software that we are running, like the compute, the network, the storage, all those managed services that we are running, it's all our responsibility to make sure that it is secure, and we are constantly patching and making sure that it is top class security that we provide from a hardware and a software infrastructure, right? That remains the same. But you really quickly touch on one thing. We also add edge locations right there, right? So it is our responsibility. When I say our, AWS responsibility, working with our carrier partners, even though it's no more in the regions, it's an edge location. When I say edge location, it's not just the POP location for CloudFront. It also includes AWS wavelength zones and local zones as part of the security of the cloud or security of the cloud. We are responsible for providing that security for you from the of the cloud perspective, right? In the cloud is still customers' responsibility. So all I'm trying to say is security doesn't change. With that, the question that the customers ask is, what about the compliance certification, right? There's a lot of key questions. A lot of customers are very concerned about security, rightly so, right? Rightly so. And we have the necessary compliance security certifications when you run your workload in the region today, right? There's FedRAMP and SOC and ISO, FISMA. There's tons of security requirements for our customers to run their application in the cloud. We constantly do audits, right? There are constantly audits is happening and making sure that we are up to date on the security certifications. So my customer questions is, that's great. Does it actually apply to my workload when I run in a wavelength zone? No. The answer is no, because as I mentioned there, it is such a distributed architecture. We have to go through additional audits with FedRAMP, with SOC, with ISO, with FISMA. We have to go through additional security audits to make sure that the security certification, which is valid for compliance, which is valid for region, is also valid for wavelength. As of today, HIPAA, PCI, and DSS are compliant. Wavelength zone workloads are compliant with these three certifications. That doesn't mean that these are the three will be supported. We are constantly working with other audit agencies, compliance group, to make sure we can add other compliance like FedRAMP, SOC, FISMA, etc., right? So this work in progress. Please keep in touch with us if you have a very specific requirements of compliance. But we will constantly update our product page to see, because when we announced GA with Verizon in August 2020, only HIPAA was allowed. Now we have added PCI and DSS compliance to it. So constantly we are adding more compliance for workloads which is running in a wavelength zone. With that, I yield back to Julia for the conclusions and next steps.
Thank you very much, Saravanan. I just, before we move to a Q&A, and please post any questions on the chat that you'd like us to respond to. I just wanted to give you an overview of the next steps. So if we can click one more time, Saravanan. The next phase is phase 2, and that is hands-on technical labs. It's going to be your opportunity to get your hands dirty and put in practice what you've learned today. It will be a slightly longer session. It will be that will be running at the beginning of February. We have 2 sessions, the 11th and the 23rd of February. We'll be running smaller sessions because we want to make sure that we, from a Vodafone and AWS perspective, can support you on a one-to-one perspective. And we'll give you AWS test accounts and access to a platform and guide you through step-by-steps on how to deploy applications on MEC wavelength. And we'll also be discussing more about the best practices in architecting your applications, delving more into the details about the key use cases and some of the services that we mentioned today. And I think it's a brilliant opportunity for those of you that are interested in having a deeper dive, a highly technical session to really put into practice what you've learned. So you'll be receiving an email early next week to invite you to the next step. I'll invite you to register for it quite quickly, as places are limited, as I said, because we want to keep them as closer sessions. So do make sure to look out for that email and to register for the session. Saravanan, do you want to add anything else onto it, or shall we move to Q&A?
No, I just want to say whatever we talked about today in terms of how Wavelength operates and how developers can deploy applications. So these labs are really tailored towards giving you a hands-on experience on accessing these services in a real lab, right? It's not an emulated lab. You're actually going to experience it firsthand, deploying a sample application, a container-based application, an EC2-based application, how to create EKS cluster, and also extend into the pilot wavelength zone that's currently in Vodafone network, and also see the value of deploying applications at the edge. And we have some cool apps that you can deploy and see what's the difference in between a region and a wavelength zone and the power of its computing. So feel free to sign up, and I can vouch that we're going to have an amazing time during that lab session.
Absolutely, very much looking forward to them, and hopefully to see many of you on the next step. We don't seem to have any more questions. Actually, there is one. Do we have some preparation documents to prepare for the lab? Saravanan, do you want to respond to that?
We actually don't have a prep doc, but we typically send you what are the prerequisites in terms of getting your system ready for the labs, right? Like downloading the AWS CLI toolkit, downloading some of the documentation and understanding about VPCs and things like that. We make sure that these labs start from the basics, right? We're not going to jump right into what Wavelength is and to deploy an application on Wavelength. It's kind of a building block, as you'll see when you join the lab. So just have the basic requirements that we will email you on what you need, and then we can certainly use the lab and answer your questions during the time. So we don't want to give the stuff that is not necessary for you to focus on. So that's why it's very simple, basic prerequisites. If you're already an AWS savvy user, it will be very simple and easy labs to kind of go with. But if you're not really AWS savvy and familiar with the tools, we certainly can augment to the email that we're going to send on what things that you can read through and focus on before you come on board for the labs.
Thank you, Saravanan. And we'll be, we from AWS and Vodafone perspective, will be there during the session to support you throughout all the steps. So yeah, please do. I think it's a brilliant opportunity to really understand what we've discussed is all about and try it yourself. Very looking forward to seeing many of you register for it. It doesn't seem that we have other questions. We have responded to hopefully all of them on the chat throughout the webinar. I just wanted to thank you all for your participation, interest. We from Vodafone AWS are super excited to be able to work and speak with you guys as you are leading and pioneering in your industries. We really look forward to continuing the journey with you. Do let us know if you have any questions. Saravanan, anything you'd like to say?
All I have to say is thank you so much for your time today. I know 200 hours is it's such a prime time, especially in the afternoon. So thank you so much for joining us. Keep the questions coming. Please reach out to us on any means and methodologies you have to AWS team and Vodafone team. We are happy to help you out in the journey of edge computing. And that's what I want to say, Julia.
And if I could just add a final note that you should be receiving a follow-up email, so please look out for that. This will give you another opportunity to ask your questions, as well as let us know your initial thoughts on any projects that you would like support on. So thank you again. We encourage you to register as soon as possible for the phase 2 training sessions, as places are limited. Thank you, everyone.